I guess so. Good afternoon all. Thank you all for coming. My name is Amin Sikander. I'm CEO of Synkrato. With me I have Patrick, who's from Zebra. The goal here today was to really kind of demystify some of these buzzwords that we keep hearing about, right? Digital twins and AI, and really give you an overview of a practical application, right? So the intent of today's presentation is to walk through a case study using Zebra, so their warehouse in the Netherlands, and walk through how we implemented our digital twin, that's Synkrato, and our AI in conjunction with Zebra's hardware to kind of build what we are hoping is the warehouse of the future, right? And we'll explain a little bit about what our vision of the autonomous warehouse is and where we think we're going to go in terms of future technology and the benefits that will accrue. With that, I'll have Patrick introduce himself and Zebra. Please go ahead, Patrick.
Hi, my name is Patrick Clark. I am the Distribution Center and Manufacturing Systems Advisor for Zebra Technologies. A little about Zebra. We are rated #1 by Gartner for our rugged mobile computing, our data capture, our barcode printing, and our mobile RFID in 2023. Zebra's been around for over 50 years. We were founded in 1969 by Ed Kaplan and Gary Cleese. We had our first handheld laser barcode scanner in 1979, and in 91, we had our first label scannable 2D barcodes. The one I like is in 2014, we became the official on-field player tracking provider of the NFL. These are the tags that you see on the NFL games telling you where the player's at, how fast they're traveling. So those are pretty cool. 2018, we acquired a product called Explore. These are rugged tablets in our solutions. And over the last 4 or 5 years, we've started moving more into a software solution to incorporate in with our hardware of our mobile devices and our printers. So Zebra does $4.5 billion worth of global sales each year. We have almost 10,000 employees across 52 countries and 122 facilities with over 10,000 plus channel partners. 6,800 patents in US and international, and 11% of our sales are R&D.
Right. That's my cue. Thank you, Patrick. My name, as I said, is Amin Sikander. My official title is Warehouse Geek. I've either been building or implementing solutions for the warehouse for all my life, 25 plus years. Started off with a best-of-breed WMS company, and then Oracle hired me to be one of the primary architects of their supply chain suite of products. Did that for a few years, and then left to co-found and run a services company that implemented WMS systems for a wide variety of different customers before starting Synkrato. All that to say is that that's the world I come from, that's the world I'm comfortable in, and I'm very, let's say, empathetic to the opportunities and challenges, shall we say, of warehousing in particular, right? So what started us on this journey, right? So a couple of years ago, we took a step back, essentially because we were tired of addressing the same problems over and over again. And fundamentally, we felt that the job of the warehouse worker, the frontline worker, hadn't substantially changed in the last 20 plus years, right? Some of the challenges that our customers were dealing with, number one is labor, right? Labor is becoming more and more of a concern. Back in 2022, about 35% of all warehousing and manufacturing jobs were unfilled. Got a little better last year, but not substantially so, right? And longer term, that's a problem that's here to stay, to the point that Gartner thinks that about 40% of businesses at some point in the next 5 years will report lost revenue just because they don't have the people to fulfill the orders they need to, right? To add to that, the second one is kind of a shocking statistic. I had to double check that to make sure that's actually right. We are one of the few industries that actually had a decrease in productivity, right? In fact, in services, I think the only one that was below us was laundry and dry cleaning. Don't ask me why that is, but that's the case, right? But if you think about that a little bit more as to why, it becomes apparent, right? That's driven by two things. One, a change in the demand patterns, right? A lot more direct-to-consumer orders, and picking cases and picking each is far more complex than picking pallets and shipping it to retail stores. That's one. It's not like people have gotten worse at their jobs. It's that their jobs have gotten harder, right? And second, I think it also speaks to the fact that these underlying systems, these WMS systems, these core ERP systems, are not really adapting to the change. And I know a little bit about this because this is sort of kind of how I made my money, implementing these systems. And if you think about these ERP and WMS systems, mostly they are static, rules-based systems. By that I mean, when you implement a system, you configure all these different rules for storage, for picking, for replenishment. But you do that for a given moment in time. As to when you implement a WMS, how your business looked like at that point of time. It's very hard to change a WMS to reflect any changes in your supply and demand patterns on any sort of semi-regular basis. And it's almost impossible to do so on a daily basis, right? Whereas I would submit that a warehouse, from a supply chain perspective, probably deals with the highest level of uncertainty on a day-to-day basis, right? Given carriers showing up late, people not showing up, a truck pulled into the wrong door, et cetera, right? All these small incremental things that add up. Now, most people look towards AI and automation to address some of these problems, right? About 95% intend to either use robotics or AI to address some of these problems. The challenge is separating the reality from the hype, right? Over 70% of people will implement some sort of Gen AI solution, but less than 10%, according to Gartner, are going to really get any ROI from it. And why is that, right? It's because when we talk about Gen AI, we have to separate Gen AI from applied AI. Some of you were probably in some of the earlier sessions when they're talking about using machine learning for forecasting. Those are fundamentally math problems that Gen AI is not really equipped to help with, right? You can still leverage AI to solve some of those problems, but Gen AI is not the answer to a lot of the supply chain concerns that we have, right? People who do adopt AI successfully, though, the expectation is that 65% of all decisions in the supply chain will be automated, which brings us to what we think is the warehouse of the future. And that comprises of three primary elements. One is what we call the human augmentation tech, and that's where, Patrick, if we can talk about some of the technology that Zebra has.
So for human augmentation, Zebra has come up with multiple devices. We have our Zebra robots. These are utilized in the warehouse to help our users complete their task. The robots will move the material from one area to another when asked to do so by the users, so that we reduce the overall travel from the users so they can keep doing their work while the robot takes care of their task. The glasses up here, those are hands-free devices, right? So we got a couple of different hands-free devices where the user's able to go pick and see that pick through the lenses without having something in their hand that they have to switch out, pick up the boxes, pick back up, move around. So really useful for the users to be able to pick quicker. We also have our RTLS devices, real-time location solutions. So our warehouse is ever growing. So we have a lot of static locations, but we have a lot of non-static locations that we can place material into. With this, you start losing material. So using these RTLS devices, we're able to use these to place material in an area and these devices will help the users know where they're at any given time.
The fact of the matter is, though, is that Zebra has all this really cool and valuable technology, right? And we heard DHL earlier in the day talking about how they're leveraging robotics extensively in the warehouse. To be honest, that's not the case for most warehouses. About 80% of warehouses have zero automation, right? Adoption of automation is still very much so in its infancy. And part of the problem is, as we are building these more complex systems with machines, with multiple systems, and with the prevalence of machine customers as a brand new channel, right? All of that really speaks to how difficult it is to orchestrate across all these multiple different systems on any sort of efficient basis for a human being, right? And that's why we believe an AI layer that can help automate, look at all these different streams of data every day, and automate a lot of these day-to-day decisions for you, that's going to be critical going forward. Right? And we'll give you an example of exactly how we use that at Zebra. The third part of it is, as we are dealing with all these different types of new technologies, we as humans have to learn how best to interact with them. Right? Now, you have all these robots running around, but we at the end of the day are a very visual species. Right? It's far easier to see something than to look at something in a dashboard, in an Excel spreadsheet. It's far easier to see something on an actual VR and AR image, right? That's kind of what we believe a digital twin can provide, a cyber-human bridge, if you will, that can also provide a powerful simulation tool, allow you to make changes, not only monitor your automation technology, but make changes. What if I put a conveyor here? Now, what if I make this entire shelf an ASRS? Is that really going to impact my efficiency? Well, let me change that. Let the AI engine take a look at that and tell me what it thinks in terms of how much my productivity is going to improve. Those are kind of decisions, those are kind of actionable information that this system can build. The goal really is what we think of as the autonomous warehouse. It's not just automated, but it's a warehouse where you're truly managing by exception. Right? Most of the regular day-to-day, the warehouse manager is free to do his actual job. We have done a tremendous job over the last 20 plus years of taking warehouse managers and trying our best to make them into system analysts. The amount of time they have to spend configuring and managing data in the systems, right? That's what we want to change. Let's talk about the specific problem that we are solving at Zebra. Patrick?
So our problem at Zebra is we found 40 to 50% of our labor cost is in travel time from picking material, put away material, right? Going to and from locations to get the material and bring it back. Our objective was to increase efficiency and order fulfillment by optimizing product placement, which is warehouse slotting. You want your ideal locations to hold your ideal parts. What's my fastest moving material? What's my slowest moving material? And identifying that, putting those in certain locations within the warehouse and driving the system to put those away in those locations. What we had was limitations with the data. So if you're doing this, if you're slotting your material in your inventory in your WMS, you're running reports trying to figure out what is your best product, what is your best location. Week over week, your order book changes. So every week somebody's going in there, they're running the report, they're changing the locations, they're changing parts in there, moving parts out of locations, moving parts into locations. So now you're spending the 40 to 50% of warehouse cost that you saved on labor for order fulfillment on your slotting process. So now you've just moved it to a different part of your warehouse. We also wanted replenishment. So we had order replenishment. When you release an order, we would replenish the items that were needed for those picks into the ground, into a better pick location for the users to pick. This caused an issue with the business because it's more of a reactive solution. You're releasing a replenishment to move material from an upper location to a better location to pick from, but you're slowing down the picking time. Now you have to go do a task in order to do your pick. So now it pushes your order fulfillment back. We also have a bulk replenishment that we had forward-looking right? So we could do a forward-looking replenishment and replenish days out, weeks out, months out. The problem the business had with that was you're telling me to replenish 10 pallets to a better location, but the 10 pallets I'm moving to a better location, 9 of them are going out as full pallets. So now I just double touched material for no reason, right? So we had 3 different solutions for the team that each solution gave them a little bit of what they want, but gave them a lot of what they didn't want. And in our system, we can't incorporate 3 different solutions as one. So we actually are partnering with Synkrato for their digital twins platform.
And I'm sure that struck a lot of a chord with all of you, right? It's a problem that every warehouse has. Very simply stated, now how do you minimize the travel time? By making sure your most popular products are closest to your fulfillment door, whether it's your dock door or whatever. Mathematically, people much smarter than me tell me that's what's called an NP hard problem, impossible to solve in real time, because what's popular changes all the time, right? Your demand patterns change, your supply patterns change, your labor constraints are different, right? And we have done this manually in the past many times as part of the services business, and it would take us a good couple of months to come up with a good slotting plan. The challenge was twofold. 1, by the time we were done, it was outdated. And 2, very hard to convince a warehouse to shut down and reorganize the warehouse to optimize it when everything changes again the next day. What really is the point, right? And that's the problem with a lot of these pure slotting solutions as well, that it inevitably devolves into some sort of consulting engagement. We wanted to simplify it. We wanted to make it have an optimization system that looks at all of this stuff and tells you daily what to do. What most to do, that is what the bang for the buck, and what to do with the inbound stuff that's coming in, right? Use the natural flow of material in and out to optimize your warehouse. You will not get to your optimal level day 1. That's not the point, right? But you're getting better every day, and you're trying to get to that optimal level eventually. How do we do that? It's a 3-step process. 1, we start off with building a digital twin of the warehouse. And we use Unity, the gaming platform, to do so. And I'll show you that in just a second. Second, we import data elements from your core ERP and WMS. And this is data that everybody has. It's orders and open ASNs and purchase orders and current inventory, items, unit of measures. That's pretty much it. And then we let you configure how your warehouse operates. How do you pick? This particular zone, do you do bulk picking? Do you do pick and pass? Do you do cluster picking? Tell us how you pick by zone, right? So once we understand that, then the AI engine can truly optimize your operations on an ongoing basis. So step 1, we started off, when we wanted to create a digital twin, our thesis was that if my daughter can create a world of Minecraft, you should be able to create a digital twin, which is, if you think about it, a fairly simple structure compared to the real world, right? It's a floor plan. There's a bunch of different zones that are assigned in that. Then you have all these different rows that you assign. Again, these would map to your core WMS or ERP system. You can then add your as many zones as you want. You can add your flows and your walls, right? Because the goal for the digital twin is to be a critical input to our AI engine. We need to know, not just from our XYZ coordinate, we need to know how long it'll take you to get from point A to point B. Any point A to any point B, right? Using a pathfinding algorithm. You create the structure to reflect what your system has. It's aisle, row, rack, bin, or whatever else the case may be. And then you define the kind of racks you have in your warehouse, racks or shelves. And again, a warehouse is not going to have 100 different types of racks. They may have 20, 30, right? So you set up each rack and say, I have a rack that's 4 levels, and these are the dimensions of each of those racks, right? And once you have that, you can say this particular zone, this particular row has these racks, right? And again, we're showing you the manual way of building it, but essentially you can say, this row has 10 racks of this particular type, right? Once you have that, the end result is something like that, looks like this, right? And this is an actual warehouse. And the goal, and the reason we create the digital twin is twofold. One is, like I said, it provides slot geometry and slot geography to the AI engine. Yes, it can do augmented reality. Don't have a lot, to Patrick's point, don't have a lot of customers that use AR for picking 8 hours a day just yet. They use it for training, and they use it on their iPad as a sort of Google Maps for the warehouse. But the hardware tech will get there, not quite there yet in terms of people utilizing that for a day-to-day, everyday picking type of activity. But it's there. It's because it's Unity, it's available in iOS and Android, and so forth. The second reason we built the digital twin is because we wanted to be able to do simulations. To say, what if I change the structure, add a conveyor or something? How is that going to impact my overall efficiency? So going back to Zebra's specific use case, Patrick, you want to talk about your warehouse?
Yeah, so in our Herrenveen warehouse, it's a smaller warehouse, and we have basically come to the point where we have more material than we can handle inside this warehouse, and space utilization has become an issue. So with digital twins, what we're looking for is to help us optimize the storage of this. Where should material be stored? What area should it be stored? What's our fastest moving material, where it goes? This also helps with external users. So a lot of companies have gone to remote worker, right? I work remote, and I work with the Herrenveen team to make system changes. It's hard to get on these calls and talk to people about locations, racking, on a CAD drawing, right? Visualizing that CAD drawing in 3-dimensional. You're able to come to this and see and explain and see where your locations are and see this is our 0-1 location, this is our 0-2 location. So you get a lot of that visualization inside the warehouse based on these racks, and it's a lot easier to communicate back and forth. You're also able to go in here and look at your capacity. As you see, these are our pallet spaces that are occupied. We have empty pallet spaces. So you'll be able to see your capacity in this warehouse as a real inventory. With the simulation, we have different tasks going on right now where we want to rearrange the warehouse. We want to add racking, we want to remove racking, we want to add sprinklers in certain racking. Imagine being able to feed that data into your digital twins and get output saying, this is your best way to do it. Before you spend $200,000, $300,000 redesigning your warehouse, adding something you may not have needed into your warehouse, and then now you have a pain point. With the digital twins, you're not touching your physical warehouse. You're doing this in here. You're getting a simulation. You're seeing how it affects your warehouse and then making a better decision based on the output of what the digital twins has given you. So it's going to help our warehouse out a lot on being able to see those upfront changes, what we want to do to change our warehouse to maximize the capacity, allowing us to see this up front instead of just using spreadsheets and Excel to do that calculation for us.
Thanks, Patrick. And to go back to my 3-step process, the first step was we created a digital twin of Zebra's warehouse. And Zebra has how many SKUs? 60,000 SKUs?
We have 160,000 SKUs, right? Not all of them are in all our warehouses, right? So like I said, we had 122 warehouses across the worldwide.
A lot of SKUs.
So 130,000 in our NL1 warehouse, 120,000 in our TX4 warehouse. So we have a lot of SKUs inside these warehouses.
And you can think about the different permutations and combinations that you have to go through to figure out what belongs where, right? So that's the first step, the digital twin. Second, we pull in data from their core ERP systems. Again, standard stuff that any ERP has. Third, we configure how your warehouse operates. How important is FIFO to you? How important is congestion to you? Right? What pick methodology do you use? What are the equipments you use? Forklifts or people? And so basic level information that allows us to figure out the base effort to perform a pick. Once we do that, we come back with a bunch of different analysis. One, We say, in a perfect world, if you had to start from scratch and you had to re-optimize the entire warehouse, how do you compare to that perfect world scenario, right? And almost invariably the answer is very poorly, because your warehouse is static, your business is not. Second, we say, all right, we understand nobody lives in that perfect world, and we understand that every move we ask you to make has its own cost. So given those constraints, what can we get you to do that is reasonable, that will still get you productivity gains, right? So the two primary outputs that we feed back to Zebra's WMS system are, one, a list of moves that we recommend that you do today. And these are moves that are, think of them as replenishment moves, but not really, not based on min-max, based really on our prediction of what we think you're going to be picking today and tomorrow, right? And our knowledge of what's going to come in today as well. Second is we send out a list of put-away suggestions for everything that's coming in. Where do we think we should put it, right? Because this product that's coming in, yeah, according to your WMS rules, it's an A class item, and it should theoretically go to the friend. But you know what? You're not going to be picking that anytime soon, not this week, or not today, right? So why take up that valuable real estate? Those are the kind of decisions that goes behind the scenes. The end user doesn't even know that all this happens. As far as he's concerned, he's just executing tasks like he normally would on his WMS system. We also provide a bunch of other analysis, things like SKU affinities. Now, if I buy milk, do I buy eggs? Sure, right? But if I buy 2 cans of milk, do I buy 4 cartons of eggs, or do I buy 6 cartons of eggs? The quantity becomes important. Once you have all that, to Patrick's point, you can go back to the digital twin. And if you search for an item, this is kind of a human in the loop sort of validation. For a given item, yes, we came back with a suggestion. This is where the visualization element becomes important, right? Like, how do you know that makes sense? Yes, we can show you an Excel spreadsheet, but let's show you on the tin. The one in the box on the red is where your inventory currently is. We really think you should move to the blue box, because you're not going to be selling that anymore, right? That level of analysis is far more intuitive in a digital twin than providing you an Excel spreadsheet. Second, you can do simulations. And there are 3 types of simulations you can do. One, you can change the physical structure of the warehouse, as I said previously. You can say, I have this empty wall here. Let me add 10 racks. And if I do that, is that going to make me more efficient? And 2, what should I actually store in that 10 racks? The second type of simulation you can do is change your data. I have a promotion plan going, and I'm expecting a spike in demand for this particular item, or I'm expecting a huge load of this product from China in 2 weeks. That's what my customers told me. How do I, as a warehouse manager, plan for that? How will my warehouse be able to react to that, right? To go to a really more predictive world, as opposed to the truly reactive world that most warehouses live in today, right? And third, you can also change how your warehouse operates. I'm using cluster picking, but maybe I really should move to wave picking or a pick and pass and put a conveyor in there. If I do that, is that going to make sense? How is my efficiency going to change? And these are metrics that are quantifiable that you can look at every day to see if it really makes sense for you to do or not. So, and those are some of the metrics that we show, right? The variability comes in based on, we send down a list of recommendations. And depending on the labor constraints that Zebra has on any given day, they may be able to do 50 of those moves, or they may be able to do all of those moves. And the variability and how much more efficient you can get is based on how much of our recommendations you're able to act on that particular given day. Like I said, the inputs and outputs, and I really wrote this down because that's really all we're using. It's not complicated, it's data you already have, right? You don't even need if you have a supply chain plan and demand forecast, great. Not truly necessary to achieve some level of optimization, right? And we do a whole bunch of forecasting and prediction around both inbound and outbound, based on your sales history, based on your open order book. What do we think you're going to be picking today? And two, based on your past history, how accurate are your A's and promise dates? Are they actually coming in the day that they're supposed to? Well, it depends on your supplier, it depends on your item, it depends on your ship method, and depends on what they have done in the past, right? So that kind of forecasting and probabilistic, which is not really AI, it's more forecasting and machine learning than anything else, right? But all of that drives the AI engine. And the reason we went AI is a lot of this is machine learning. A lot of this is forecasting, right? But we're using AI to kind of automate, to simplify, to make it scalable. Because without that, we're going to have to model this for every warehouse we go to, right? With the AI engine, we're able to put in a simple model where you can configure all these parameters, and the AI engine looks at what you're doing every day to figure out what you should do tomorrow. Phase two.
Yeah, enabling the frontline workers. So this is one of our Zebra devices, our handhelds. What we're doing is we're adding AI to our handhelds, right? So we know that when users out there picking, there's some things they forget. They don't fully know their work instructions, right? So now you have to walk back up front, find the work instructions, come back. We're using our tools to allow the users to ask a question inside the device and return the answer in an AI, right? So no more walking back and forth. If you have a question, you can ask it on the mobile device, get an answer. Part of the second phase will be to work with Synkrato to not only use our training documents, work instructions with this AI in our tool, but to also work with them on our WMS to pull more understanding as far as our WMS data goes.
Yeah, I mean, the Gen AI can be extraordinarily useful, right? If it's focused on the right problem and if it's constrained to the right data set and trained to the right data set. Without that, it just becomes too hard. We're not trying to solve the world's problems, right? We just want to answer the questions of the warehouse. So if you ask our Gen AI, hey, what do you think the weather in Tokyo is going to be next week? It's going to say, no idea. I'm a warehouse bot. That's all I know. Ask me what you're going to be picking next week. I can help you with that, right? So that's how we eliminate hallucinations. But we do that by constraining it to just the data that we're training it on, right? What we're using the Gen AI for is threefold. One, it's an excellent business analyst at your side, right? Ask any questions that you want, and it's awesome at looking at the data that we have trained it on to come back with relevant results. Are there any opportunities for cross-talking? How many people do I need today, tomorrow, based on data coming from our AI engine, our applied AI engine, as well as your core ERP data. Second, I think of it as the world's best report writer because you can ask it whatever you want, and it's awesome at this stuff. This is the kind of stuff that's feels like magic sometimes, right? Rather than having a team of analysts building reports for you constantly, just ask it a question and have it come back. The third piece, and this is a little bit of a longer term, is its ability to change unstructured data to structured data. By that I mean taking a photo of a pack slip, taking a photo of a pallet, and asking it, what is this thing? What am I supposed to do with it, right? And having it translate that unstructured data, whether it's a document or an image, to meaningful structured data that it can then build inferences and answer questions on. Right? That's kind of what we're using Gen AI for. Again, this is only useful when it's trained for specific systems and specific data, right? It's not something you can say, okay, now that it's answering my warehousing questions, let me start asking it financial questions. No, I can't do that, right? We had to spend months training it on that. All right, so we're out of time, but so when we're talking about the AI, we're not talking about slotting, which is just one part of the problem that we're solving. We're seeing AI as this complete optimization system for the warehouse that sits between automation and your core WMS system. Think of it like, there was a question earlier at Song's presentation, I think it was, is it a WCS or a WES? Well, we think of this as a WOS, so an optimization system, right? That all it does is, it's a recommendation engine for your WMS. That's the simplest way to think of it, right? It doesn't replace a WMS, it just makes a WMS smarter. And it does that by building all this prediction and forecasting engines, and it does that by doing labor forecasting, by doing order workload forecasting, by doing dock optimization, which for Zebra, it's not a problem, right? They don't have, how many dock doors do you have, Patrick? Probably about 15?
In NL1, probably 4 or 5. In TX4, we have 15, maybe 20.
20.
Yeah.
But there are customers that have like 150 plus dock doors, right? Yes. And it's a constant struggle, manual struggle every day to assign appropriate carriers to appropriate dock doors. And now you also got to consider which dock door a particular carrier is coming in when you're talking about this entire slotting piece as well, because it makes no sense to put it in front of dock door 1 when it's going to be shipped out tomorrow from dock door 50, right? So as you get deeper into this, there's a lot of these optimization issues that we think can be solved that can augment your existing systems. With that, Patrick, future roadmap of where we are going to go with Zebra.
Yeah, global unified digital labeling platform. So we've rolled out our labeling platform with Synkrato. We're working on our digital twin for NL1, so this is what we just showed, for AI-driven warehouse slotting. In phase 2, we're rolling the same digital twin out in our Kenosha facility in order to use warehouse labor forecasting along with our robotics integration into digital twin. So we're hoping to integrate our robots into the digital twin so they'll be able to use suggestions from the digital twin as well. AI-driven operations along with our connected resources, our RTLS devices for storage locations, task resource planning, and the Gen AI chat. And our phase 3 will be process automation, AR-based picking, drone-based counting, predictive logistics.
Because with Zebra being Zebra, and obviously them being the leader in RTLS and RFID, right now we're measuring efficiency based on what you've done based on the data, right? We look at, okay, you did 25 tasks without outsolutions, now you're doing 20 now, and this is how much you've traveled, right? With a true RTLS system, we'll be able to measure exactly how many miles they're driving per day, right? Putting an RFID chip on every forklift so we can track not only how much we are saving more granularly, but also be able to dispatch the appropriate task to the appropriate resource. Because one of the problems with the WMS system typically is that it knows what it did last, right? It doesn't know where you are now. That's why you need an RTLS system. Even if you're not using an RTLS system to constantly have real-time inventory tracking, you can use that to have real-time resource tracking, whether that be robotics or whether that be people. The goal, like I said, is some of this is not there yet, right? Drone-based counting, there are companies that do this. There's still some challenges with technology where it's great at doing first level, but if you have like 2 or 3 pallets stacked up one in a row after each other, it doesn't really do a great job of that. We even tried having a pallet, and we took one box out of a pallet and asking a Gen AI to say, how many boxes are there in this? Couldn't do it. It's simple. So there are things that it's excellent at, but there are other simple things that look simple, but are not quite, right? So we'll get there, obviously. The pace of change in AI is truly astounding. Not there yet, though. All right, I think that's leaves us about exactly 6 minutes for questions. I'll open it up to
dark data transformation.
Dark data is I have to apologize. It's a Silicon speak for converting unstructured data to structured data. So unstructured data. Any manufacturing organization, for example, will have a huge treasure trove of these PDF documents, whether they be manufacturing routers or QA documents that people typically scan and upload in the document, right? Yes. There's a lot of data and intelligence that can be derived from that if we could only convert those PDFs into actual structured data and be able to make inferences based on that.
So from hard copy to digital copy.
And use AI on top of that is the key, yes.
Okay, I understand. Thank you.
I don't know, doc,
Storage of data.
Yes. One of those warehouses that have about 800 different boxes sitting around with all your data lying around. Yep.
So I had a warehouse that I was managing for a while where we had, be careful with my language, there's 2 bays wide, or 1 bay is 2 pallets wide. And then you had 6 levels high in the warehouse of a racking system. And I say that specifically because I had a pallet in each alpha level location all the way up to after 5 stars, what I called it, to 16 pallet locations of nothing but banker's boxes with documents just like that that were required to save.
Yes. Hard
Yes.
copies, yes.
and people also use it now more and more for things like invoice payment, right? Or a pack slip comes in, a supplier sends in an invoice, you have that as a PDF, and you convert it. It's still a little expensive though, which is what we're holding off on now.
But Iron Mountain made their money for
Yeah.
retention forever, especially if you're working on government contracts, because there are 7-year, 10-year rules for
Yep,
retention of
yep,
documents. Unless you can convince an electronic storage is secure enough
That's
and long-lasting enough. Not a fun argument to make, but it's a problem.
Yep.
I would love to go to
That's it.
electronic storage.
No, but even if you had to have the paper, if you were able to actually make meaningful decisions or inferences from that paper, right? That I think is
Of course,
very,
of course. We're
hugely
talking
valuable.
everything from doc receipts to technical data packages or literally printed with handwritten notes on it that could be stored
Right.
for engineering
That's it.
purposes later on down the line. Absolutely. I see all the benefits right away, and that's why I was
Yep.
kind of like, ooh, yeah.
No, it's possible. We can do it now. The
Yes.
question right now is it's too expensive to do like millions of pages, frankly.
The upfront
it'll come
cost
down.
of that would be astounding.
Yep.
Especially for a large company with decades
Decades
worth
of-
of documents.
yes.
But from a starting point of now moving forward,
Yes.
retroactive,
That's a-
no.
yes.
But going forward, yes.
Yep. I agree with you on that.
Somebody else hopefully has some comments besides me. I feel bad.
I think it was Karen. I took my picture, I think it was Karen.
It was a good presentation.
Yeah.
Thank you.
yes.
Yeah.
That's why there's not a whole lot of questions besides a minor definition problem with dark
But-
data.
No, hopefully, I mean, our goal was to make it clear that this doesn't have to be complicated, right? I mean, building a digital twin funnel takes us less than a week, starting from scratch, nothing, right? So it doesn't, like I said, you ask your daughter to do it for you, and she probably will get done in a couple of days or a day.
Well, except for the true logistics nerds out there, I mean, box scrapers from way back who just hate wasting time on documents. You're at the unfortunate place at the end of the day for the last session, right before people get to either
Yes.
people or leave.
Yep.
So there's not a lot of questions left.
I do have one question.
Yes.
I work in a situation where we contract a third party to run our warehousing operations.
Uh-huh.
We've got data streams coming from 2 different places. In that kind of implementation, are you able to integrate data from both, or would you?
Yeah, no, we don't care, right? And in fact, some of our customers use 3PLs to run their warehouses, right? And it's simple, like I said, whether it's a 3PL or not, the data is the data. It's common data that every WMS and ERP has.
You start with a blank slate.
And at the end, it's suggestions, right? So we're telling our team, even those suggestions, use them, right? You gave us the rules. This is exactly what you wanted. Use them and give us, in the digital twins, let us modify this stuff. Use it, tell us what we need to modify, and fix it, right? Don't don't just override stuff and do it. We want to make sure this thing actually
Works, and it learns
tells
from
you,
you what you're doing. Yeah.
right?
Is that what you called the phrase was continuous optimization?
Yes.
So it's not a
Yep.
fixed item that's like, here's your tool and you can only use it for.
No. It's our I forget who said this quote, but they never let the perfect be the enemy of the good, right?
Yes.
Yeah. So we won't get to in a perfect day one, but no, let's start getting better every day, right?
Well, continuous improvement is one of the buzzwords from way back. Continuous optimization is a better way of putting
Yep.
it, yes. Well, it's been around for 2
And I don't know if Amin knows, but when we first started with Synkrato on the digital twin, I was actually working on replenishment in our warehouse. And I didn't see Synkrato. I was like, I don't want that. I got replenishment. I'm doing this, right? Let's do our system. Then they show me the digital twins, and I'm like, there's no way I can do it. Like all the stuff that this is going to do for us, everything I was looking at, I could put it together, and I still wouldn't get what they're going to give us at the end.
You described in your presentation for replenishment, stock rotation, optimization for placement for fast-moving items versus slow long-term storage. Had all in the warehouse. I did it on a printed map with
Yep.
notes, and then I did it on Excel spreadsheet.
Yep.
It's
Been there, done that. Yes.
It's unfair.
Yes.
And nowhere near as good. Even on my best day, on my sharpest pencil, could I come anywhere close to what
Yep.
you have there? So no, I appreciate it.
We had this in our NL1 Heron the slotting, right? They were doing slotting and replenishment. I think that lasted about 3 months before they said, we can't pull this data. We can't. Everything we do is wrong. We put it in there, the next week it's wrong. We put it in there, the next week it's wrong.
I could do it
So-
once, but the constant updating of
Yep.
the data, there's just no way. I don't have enough time in the day to be able to do it, even if I could mentally be able to keep up with it.
Hands-free. The user will see, after we're done with our integration, the user see nothing. When they go scan their item to put it away, we've already have the suggestions, replenishments. Our
Instant reporting is another thing that you can geek out over because I don't know how many times let me parse my words carefully. There's so many higher-ups that have asked for a pretty pie chart or graph on a drop of a hat where I have to drop everything to create the data for them.
I know.
That is beautiful.
Yeah.
Just so I don't have to make nice.
Yep. As long as you're sure it's not making up stuff, right? Which is where we had to spend the most time on. Just look at this stuff, nothing else, right?
Yes. I have nothing further. I'm ready to go.
Anybody else? Any questions? Feel free to reach out to either of us. Happy to answer any questions. Otherwise, have a good rest of it. Thank you. Thank you, Patrick. Yeah.